Okay, let's move on to trilateration. We're using the same site. We're still working on the same site. We have our baselines, baseline 2, baseline 1, and as you can see, the canon 2 that we plotted with offsets is still there. And we're going to be building our rec site, our site map. So we use the same thing. We keep building onto the same site map. For trilateration, you'll need more or less the same equipment: a pencil, a ruler, a sharpener, a rubber in case you make mistakes so that you can change them, your graph paper for the site map, and of course your measurements that you took on your trilateration recording form. And in addition, you'll need a mathematical compass, a drawing compass. Now, if you remember, instead of using measurements along the baseline, we marked off points at regular intervals on our baseline and we marked them. In our case, we used centimeters, 1, 2, 3, 4, etc. But these may be meters, there may be 2 meters in between. We need to remember what that is to determine our scale, but these are marked points along the baseline rather than points that mark a distance. So if these were 2 meters, we would still call it 1. We'd still call that at 4 meters 2, at 6 meters 3, and so on, up the baseline. But we would know that the distance between 0 and 1, 1 and 2, 2 and 3, 3 and 4 is 2 meters rather than 1 centimeter or 1 meter, and we would need to adjust our scale accordingly. However, once we have the scale, it's easy enough to convert to our measurements from the trilat recording form and onto our ruler when we're doing plotting our positions. Again, in our case, we know that these are centimeters. So a centimeter here equals a centimeter in real life. But it could be that this represents 2 meters, in which case a centimeter on the page would represent 2 meters in real life. In other words, for every measurement you took of 2 meters, you would draw or measure a centimeter on this page. So we need to remember scale. It's important. Luckily for us, we're working at 1:1, so we'll just work in centimeters and we'll call our datum points along the baseline in centimeters. And we would have done the same along here on baseline 2 if we had done trilateration from baseline 2. Remember that you want to keep the scale on the 2 the same. So this is a little more complicated than the offsets where you measure along the baseline and off the baseline, in that we have 2 measurements for each point that we want to plot. So let's go back here. Let's follow the headings in each column. So we know we're working for baseline 1. So we know that we're working on this baseline. The point that we're looking for, or we're going to plot, is point number 3, which was the front of cannon 1, and point number 4, which was the back of cannon 1. So let's move along. Point number 3, the baseline marker that we measured from was 0.8, and the distance from that to the point that we're trying to plot was 6.5 centimeters. So we need to do, firstly, with our compass, we're going to look at the distance from the baseline or from the datum point to the object, which in this case was 6.5. So let's measure out 6.5. Put the 0 on your ruler and the tip of the pencil on the measurement, the distance measurement on your ruler. So we know that the front of the cannon was 6.5 centimeters from 0.8 on our baseline. So let's go to our baseline, and there is 0.8. Now we don't know exactly where it was 6.5 centimeters. It could be anywhere. We know that it's on the left-hand side because we wrote that down, but it could be anywhere from the baseline around to the baseline, 180 degrees. So let's go back to our site sketch. And in our case, we can look directly at our site. We know that the cannon is more or less in this area. So we know that it's not down here, we know that it's not up there, we know that it's somewhere over there. We can also look at our trilateration form, and we took measurements, if you remember, from either side of that point. So somewhere between baseline marker 8 and baseline marker 13 is going to be where our point is. So we don't need to draw the entire 180-degree arc, we just need to draw something between those 2 points. So let's look at that. We put the 0 on point 8, which is where we took the measurement from, and we draw an arc 6.5 centimeters away, which is the distance that we got for our measurement. And we know this is roughly where the back of that cannon was, or the front of that cannon. But that's only one point. We need to fix where on that arc the back of the cannon was. So we go to our next one. From baseline marker 13 was a measurement of 7.7 centimeters. So let's measure out 7.7 centimeters on our ruler. Put the point at 0 and the point of the pencil on 7.7, and we go put the point on marker 13, and we put the arc 7.7 centimeters away, where it crosses the first arc that we drew. Now, we can see that I made a mistake. I misjudged where the cannon was in relation to those 2 points. So let's go back to our first baseline marker, marker 8, 6.5 centimeters, and we will redraw that arc just to make sure that it crosses in the right place. So let's get rid of our mistake with the rubber, and let's just check our measurement. It's easier to double check here than to try and find mistakes later on. So there we are, 0 to 6.5, 0 on marker 8, and we draw our arc. And where those 2 points intersect is the point that we're looking for, which was point number 3, which we know was the front of the cannon. Now, we need to find the the back of the cannon as well. So let's look at the measurements we took there. Point number 4 was the other end of the cannon, and from baseline marker 4, we had a measurement of 10.2 centimeters. So we measure out 10.2 centimeters with our compass, 10.2 centimeters on our compass. We go to baseline marker 4, put the point of the compass on the baseline marker, and we draw an arc. We know roughly where it is, so we don't have to draw, or the direction that it was, so we don't have to draw a huge arc. My apologies. I will do that again, as I made a mistake there. As I said, don't worry if you make mistakes. They do happen frequently, and it's better to take your time doing this than to rush through it. So we measured again, and we will draw our arc again. The second point we had was from baseline marker 12, and that was 10.1 centimeters to the back of the cannon. So we remeasure 10.1 centimeters from baseline marker 12, and where they intersect is where our second point is, and this was point number 4. As we did with the first cannon, we can draw a line that connects those 2 points, label it cannon 1 if we so wish, and there we have plotted 2 cannons from our shipwreck site onto the graph paper, or at least we've plotted the orientation and the position of 2 cannons in relation to each other and in relation to the baselines, and we will continue to do that for the other objects on our site. In the next video, we'll look at detailed drawing and see how we convert these lines and points into objects that make sense and look like the objects on our site.